close your eyes for a moment and imagine. When you think of Mercury, what comes to mind? Just a small planet circling closest to the sun? Or could there be more? Secrets that most people have never heard. What if I told you Mercury hides water ice in places where sunlight never reaches? That it carries an oversized iron heart, larger than any other planet's? Or that its orbit once puzzled scientists so deeply it helped prove Einstein's theory of relativity? Why does this tiny world have cliffs taller than the Grand Canyon? How can it be both the hottest and coldest planet at the same time? And why are there strange hollow pits on its surface that no other planet has? Tonight, we'll drift through 100 of these little-known facts, rare details that show Mercury is far more than just a quiet rock near the sun. Let's begin the journey and let curiosity guide us deeper into its mysteries. Before we begin, don't forget to subscribe for more calming journeys through space, and tap the like button if you enjoy drifting into these cosmic stories. Now, let's begin. Mercury is the smallest planet in our solar system, and also the one closest to the sun. Yet, despite this, it is often forgotten. Its brightness in the dawn or evening sky is fleeting, and because it hugs the sun so tightly, it is difficult to observe. Many people know more about Mars, Venus, or Saturn than they do about Mercury. But in its quiet way, Mercury holds some of the most astonishing extremes and mysteries. It has been shaped by fire, ice, and time itself, becoming a living record of the solar system's earliest history. Mercury has no discovery date because humans have always known it. Ancient sky watchers noticed its quick dance near the sun. To the Babylonians, it was a celestial wanderer worth tracking carefully. To the Greeks, it appeared so fast that they thought it was two different stars, one that rose in the morning and another that appeared at sunset. It is one of only 5 planets visible to the naked eye, and so it has been part of human stories for thousands of years. To look at Mercury is to share an experience with countless generations past. In early Greek astronomy, Mercury was not one planet, but 2. When it appeared in the morning sky, shining before the sun, the Greeks called it Apollo. When it returned in the evening, following the setting sun, it was called Hermes. For a long time, people did not realize these 2 stars were the same object. The planet was eventually recognized as one, but its dual identity became part of its myth: fast, clever, and always moving between night and day, messenger of the gods. This duality still lingers in Mercury's mysterious presence in the sky. When the Romans adopted Greek astronomy, they gave the planet a single name, Mercury. To them, it embodied the swift-footed messenger god, always in motion, always close to the power of the sun. The choice was fitting. Mercury completes a full orbit in just 88 Earth days, making it the fastest planet of all. Just as the Roman god Mercury was said to travel quickly with messages from Olympus to Earth, the planet Mercury races endlessly around the sun, carrying secrets of the inner solar system. The name has stayed with us for over 2,000 years. Far from Europe, ancient Chinese astronomers were also watching Mercury. Their star maps, carved and painted long before telescopes existed, recorded the tiny planet's movements. In Chinese tradition, Mercury was linked with water, darkness, and mystery. Its dim light, appearing only close to the sun, was seen as an omen of change. These records show us that even though Mercury is difficult to see, it has been part of global human culture for millennia. Across civilizations, its flickering presence inspired stories of swiftness, transformation, and hidden power. Even though Mercury has been known since ancient times, it is not easy to observe. Because the planet never strays far from the sun, it is usually hidden in the glare of daylight. To see it clearly, you must catch it just after sunset or just before sunrise, when the sky is dim enough to reveal its glow. This fleeting window of visibility gave Mercury a reputation for being elusive. For many people, it was a rare sight, a small, shining messenger slipping quickly into the horizon, as if afraid to linger too long in human company. When Galileo turned his telescope toward Mercury in the early 1600s, he expected to uncover its secrets. Instead, he found disappointment. Mercury appeared so small and so blurred in his lenses that no surface details could be seen. Unlike the craters of the moon or the moons of Jupiter, Mercury revealed nothing. The planet's tiny size, harsh glare from the sun, and shimmering in Earth's atmosphere all combined to keep it hidden. For centuries after Galileo, astronomers struggled to study Mercury, relying mostly on guesswork and fleeting observations. As telescopes improved in the 1800s and 1900s, Mercury slowly revealed more of itself. Careful observers noted faint markings on its disk and attempted to chart surface features. Many of these maps turned out to be inaccurate, blurred by the challenges of observing the planet. Yet even these flawed sketches showed one important truth. Mercury was not smooth and featureless. Like the moon, it bore the scars of impacts and geological history. These early efforts laid the groundwork for later discoveries, showing that patience and persistence were needed to unlock Mercury's mysteries. One of the earliest great achievements in astronomy was calculating Mercury's orbit. Astronomers tracked its speed and path through the sky, noting how it raced around the sun faster than any other planet. They realized Mercury completed one full circuit in just 88 Earth days. This made it unique, the shortest year in the solar system. But this rapid orbit also came with mysteries. Mercury's path was not a perfect ellipse, and the slight wobble of its movement would one day lead to one of the most important scientific breakthroughs of all time. For decades, Mercury's orbit troubled astronomers. Its closest point to the Sun, called perihelion, shifted slightly each time it circled. This movement was too large to be explained by Newton's laws of gravity alone. Scientists tried to solve the puzzle by inventing a new planet, Vulcan, that was supposed to orbit inside Mercury and tug on it. But Vulcan never appeared. The mystery of Mercury's drifting orbit would remain unsolved until Albert Einstein published his theory of general relativity in the early 1900s, finally explaining the strange procession with the warping of space-time itself. Mercury races through space at an average speed of nearly 48 kilometers per second, faster than any other planet in the solar system. To put this in perspective, Earth travels at about 30 kilometers per second. Mercury's speed is so great that if you could ride alongside it, you would circle the Sun in just under 3 months. This furious pace is a direct result of its closeness to the Sun, whose powerful gravity pulls Mercury into a tight, rapid orbit. It is as if Mercury is constantly running, never allowed to slow down in its endless race. On Mercury, a year is only 88 Earth days long. That means, if you lived there, you would celebrate your birthday more than 4 times as often. But while its years are short, Mercury's days are very long. The combination of its rotation and orbit means that a single day, from sunrise to sunrise, lasts about 176 Earth days. In other words, a day on Mercury is twice as long as its year. This strange mismatch creates a world where time feels distorted, where light and darkness stretch into extremes that earthly minds can barely imagine. If you were standing on Mercury's surface during sunrise, you would see something extraordinary. The sun would rise slowly, then appear to stop, drift backward, and rise again. This is caused by Mercury's unusual orbit and rotation working together. Such a sight would be unlike anything seen on Earth. A sky where the sun hesitates, dances, and moves in ways that defy expectation. For ancient watchers, this would have seemed like pure magic. For modern astronomers, it is a reminder of the delicate clockwork of the solar system and how differently each world turns beneath the stars. Mercury's orbit is not a neat circle. Instead, it is a stretched oval called an ellipse. This means that sometimes Mercury is much closer to the Sun than at other times. At its nearest point, it lies only about 46 million kilometers away. At its farthest, it stretches out to 70 million kilometers. This difference makes Mercury's surface temperatures wildly unstable. As it swings around the Sun, Mercury is pulled and pushed by gravitational forces. A reminder that even small planets live under the constant tug-of-war of celestial mechanics. Because it orbits so close, Mercury is held tightly in the Sun's gravitational grip. This grip not only speeds Mercury along, but also distorts it, subtly affecting its rotation and interior. The Sun's gravity has even locked Mercury into a special rhythm called a 3-to-2 resonance, meaning Mercury rotates 3 times on its axis for every 2 orbits it makes around the Sun. This odd balance ensures that some regions of Mercury experience far more sunlight than others, creating a world shaped by both fire and shadow, forever dancing to the pull of the Sun. At its closest point to the Sun, Mercury comes within about 46 million kilometers. This position is called perihelion, and it is one of the reasons Mercury is so intensely heated during the day. When Mercury swings into perihelion, it is bathed in sunlight stronger than any other planet experiences. The Sun would appear more than 3 times larger in Mercury's sky than it does from Earth. Imagine standing there under a blinding giant star, so near that its presence would feel overwhelming. This extreme closeness is a reminder of Mercury's fragile position, forever racing at the edge of the Sun's blazing grasp. At the farthest stretch of its orbit, Mercury drifts about 70 million kilometers from the Sun. This point is called aphelion, and here the planet feels slightly more at ease, though still bound tightly by gravity. The difference between perihelion and aphelion is vast, creating one of the most elliptical orbits of any planet. As Mercury swings outward, its speed slows slightly, then accelerates again as it plunges back inward. This dance of near and far gives Mercury a rhythm of extremes, a pendulum motion written in the language of gravity and light. On Earth, we are used to the Sun's steady march across the sky. But on Mercury, things are different. Because of the planet's unusual orbital speed and rotation, the Sun can appear to reverse its direction in the sky for a time. Imagine standing on Mercury's surface and watching the Sun rise, pause, slide backward, and then continue forward again. This strange retrograde motion would feel surreal, as though time itself had hiccuped. For astronomers, it is a striking example of how orbital mechanics can create unexpected patterns. For dreamers, it is a vision of a sky that refuses to behave as expected. For centuries, Mercury's orbit puzzled scientists. The slight shift of its perihelion could not be explained by Newton's laws. The answer finally came in 1915, when Albert Einstein's theory of general relativity showed that space itself was curved around the Sun. Mercury's orbit fit Einstein's equations perfectly, becoming one of the first and most dramatic proofs of his theory. In this way, Mercury played a starring role in rewriting our understanding of the universe. Its small, swift path around the Sun helped reveal that time and space are woven together in ways more mysterious than anyone had imagined. Every orbit, Mercury experiences the push and pull of gravity from not just the Sun, but also from other planets, especially Jupiter. These tugs cause tiny variations in its motion, making Mercury's path a constantly shifting track through space. Over millions of years, these small changes add up, creating cycles that alter its tilt and spin. This ongoing dance shows that Mercury is not just a static rock, but a participant in the solar system's great gravitational symphony. Even the smallest planet has its role to play in the endless balance of celestial motion. Mercury is the tiniest of all the planets in our solar system. With a diameter of just 4,879 kilometers, it is even smaller than some of the moons of Jupiter and Saturn. Only Earth's moon is comparable in size, and Mercury is only slightly larger. Yet, despite its small body, Mercury holds its place as a planet, not a moon. Its independence, orbiting directly around the Sun, makes it a world in its own right. In its smallness lies resilience, a reminder that size does not always measure importance in the grand story of the cosmos. Looking at Mercury through a telescope, you might think you are gazing at Earth's moon. Both worlds are heavily cratered, both lack thick atmospheres, and both reflect sunlight with a pale, dusty glow. But Mercury is no mere twin. Its density is much higher, its interior more mysterious, and its story far older in some ways. While the moon is Earth's companion, Mercury is a lone wanderer, shaped by the same kinds of cosmic forces, yet carrying a different fate. The similarity is striking, but the differences tell us that no two worlds are ever truly alike. For such a small planet, Mercury is astonishingly dense. In fact, it is the second densest planet in the solar system, after Earth. Scientists believe this is because Mercury has an oversized iron-rich core that makes up about 85% of its radius. This means that deep beneath its battered crust lies a giant ball of molten and solid metal. The high density is a clue that Mercury once experienced violent events, possibly collisions that stripped away lighter materials, leaving behind the heavy, metallic heart that defines it today. Unlike Earth, where the core is only about half the planet's radius, Mercury's core dominates its interior. This enormous metallic heart suggests that Mercury is a world built from iron and fire. Such a large core also explains its magnetic field, which is unusual for such a small body. Some scientists even think Mercury may once have been a larger planet that lost much of its outer shell in a massive impact. Whatever its past, the presence of such a large core makes Mercury an outlier, a world that defies the rules written by its neighbors. Mercury's radius is just 2,439 kilometers, less than half that of Earth. Its mass is only about 5.5% of Earth's. Yet despite this small size, its density means it is heavier for its volume than most planets. If Mercury were the same size as Earth, it would actually weigh more. This balance of small body and heavy heart gives Mercury a unique fingerprint among the planets. It is as though the planet has chosen to carry its weight deep inside, hidden from view, but shaping everything from its magnetic field to its gravity. If you were standing on Mercury, you would feel much lighter than on Earth. The planet's gravity is only 38% of Earth's. That means a person who weighs 70 kilograms on Earth would weigh just 26 kilograms on Mercury. You could leap higher, walk with ease, and feel almost as though you were gliding. Yet, despite this gentle pull, Mercury is still strong enough to hold on to a thin layer of atoms, creating its fragile exosphere. Its gravity, though weak, binds it to the sun and keeps it in place within the solar system's order. Mercury's entire surface area is about 74 million square kilometers. To imagine this, it is less than the total land area of Earth. In other words, if you could pick Mercury up and lay it on Earth, it would cover only part of our continents. Yet on this small surface lies a record of billions of years of history, etched in craters, cliffs, and plains. Every square kilometer tells a story of impacts, eruptions, and cosmic forces. The smallness of Mercury's surface only makes it more precious, like a tiny stone holding infinite layers of memory. Some scientists believe Mercury was not always as small as it is today. Evidence suggests it may have once been a much larger planet, possibly twice its current size. Long ago, it may have been struck by a massive impact that stripped away its lighter outer layers, leaving behind the dense metallic core and thin rocky crust we see today. If true, Mercury is a survivor of unimaginable violence, a world reduced but not destroyed. Its scars and density whisper of a past when it was something greater, now condensed into a shrunken, but enduring form. Mercury is nearly a perfect sphere, but its shape has been slightly altered by the Sun's powerful gravity. Tidal forces stretch and squeeze it as it orbits, creating tiny bulges. These distortions are so subtle that they can only be measured by spacecraft instruments, yet they reveal important details about Mercury's interior. They suggest that part of its core is still molten, shifting under pressure. Even in its silence, Mercury's shape is not rigid, but alive, moving gently under the invisible hand of the Sun. Unlike Earth, which is tilted at 23.5 degrees, Mercury has almost no axial tilt at all, less than 1 degree. This means it does not experience seasons in the way Earth does. The Sun always rises and sets along nearly the same path in its sky. Yet this lack of tilt creates other wonders. At Mercury's poles, some craters never see sunlight. These eternal shadows hide secrets of water ice preserved for billions of years. So even Mercury's stillness, its refusal to tilt, has carved out a place for mystery at the edge of its light and dark. Mercury's surface is scarred with craters of every size, evidence of countless impacts across billions of years. From tiny pockmarks to basins hundreds of kilometers wide, each crater records a moment of cosmic collision. Unlike Earth, which heals through weather, erosion, and plate tectonics, Mercury has little to erase these scars. As a result, its face is like a memory board, preserving the violent story of the early solar system. To gaze upon Mercury is to look back in time, seeing the marks of a universe still finding its balance. One of the most dramatic features on Mercury is the Caloris Basin, a vast impact crater stretching about 1,550 kilometers across. It was formed by a colossal collision more than 3.5 billion years ago. The energy released was so immense that it reshaped the entire planet, sending shock waves around to the opposite side. The basin is surrounded by mountains and ridges, frozen waves of stone left behind by that ancient strike. Caloris is not just a crater. It is a wound that defines Mercury's history, a reminder of the violence that shaped all the inner planets. Mercury's craters carry names that celebrate human creativity. Unlike the Moon, where craters are named for scientists and explorers, Mercury's craters are named after artists, writers, and musicians from across history. You can find craters honoring Beethoven, Shakespeare, and Rembrandt. This naming tradition connects the scars of Mercury with the brilliance of human imagination. It is as though every impact, every ancient event, is paired with a voice of art, linking cosmic destruction with human creation. The names turn Mercury into a celestial gallery, where the silence of space meets the music of culture. Across Mercury's surface, enormous cliffs called scarps stretch for hundreds of kilometers and rise up to 3 kilometers high. These scarps are the result of the planet shrinking as it cooled. As the metallic core contracted, the outer crust wrinkled and folded, cracking into massive cliffs. They look like frozen waves, as if the surface of Mercury had rippled and then hardened in place. These scarps show that Mercury is not just passive rock, but a world that has moved and shifted, its skin folding under the pressure of its cooling heart. Even today, Mercury is believed to be slowly cooling. This cooling continues to shrink its interior, creating more scarps and ridges over time. Unlike Earth, where tectonic plates are constantly moving, Mercury's crust is a single shell that cracks as the planet contracts. This ongoing process means Mercury is still evolving, even if at a pace too slow for us to see. In its silence, it is a world that breathes ever so faintly, whispering change over billions of years. Each cliff and ridge is part of this quiet, endless transformation. If you could glide slowly over Mercury, you would notice that the surface is folded and wrinkled in many places. These folds, called lobate scarps, stretch for hundreds of kilometers. They were created as Mercury's iron-rich core cooled and shrank, forcing the outer crust to buckle. Unlike Earth, where continents shift constantly, Mercury has no tectonic plates. Instead, its entire shell pressed inward on itself, cracking like the skin of a drying fruit. These wrinkles are frozen reminders that even a planet can contract with age, quietly reshaping itself in the stillness of time. Mercury may look like a quiet, lifeless rock today, but in its youth, it was fiery and active. Vast areas of its surface are covered in smooth plains formed by ancient lava flows. These plains tell us that volcanoes once erupted across Mercury, spilling molten rock that flooded craters and lowlands. Although no volcanoes remain active today, the traces are unmistakable. They show that Mercury was once alive with heat, reshaping its face in great fiery waves. The silence we see now is only the final stage of a world that once roared with fire. The lava plains on Mercury are not small patches, but enormous blankets of frozen rock. These plains extend for hundreds of kilometers, creating wide, flat expanses between craters. They formed long ago when lava seeped up from the planet's interior through cracks in the crust. The lava spread out and cooled, leaving behind a surface smoother than the heavily cratered highlands. To this day, These plains are one of Mercury's most defining features. They remind us that even the smallest planet once had the power to reshape itself on a vast scale, glowing with molten energy. One of the strangest features discovered on Mercury is something called hollows. These are shallow, irregular depressions scattered across the surface. They are bright and fresh-looking, unlike the ancient craters around them. Scientists believe hollows may form when volatile elements within Mercury's crust are vaporized by heat or solar radiation, leaving behind empty pits. Hollows are unique to Mercury. No other planet shows them in this way. Their appearance suggests Mercury is still subtly changing today, releasing hidden materials from beneath its surface. They are small whispers of activity on a planet long thought to be silent. While most craters on Mercury are simple bowls, some are more complex. In certain places, giant impacts created craters with not one but two rings of mountains inside. These double-ring craters formed when massive collisions melted and rebounded the crust, leaving multiple circular ridges behind. They are dramatic reminders of the scale of impacts in Mercury's past. To stand on the rim of such a crater would be to gaze across a frozen sea of stone, sculpted in an instant of unimaginable violence billions of years ago. Some of Mercury's youngest craters are marked by bright streaks radiating outward for hundreds of kilometers. These rays were created when impacts blasted fresh, reflective material across the surface. Over time, sunlight will darken these rays, but for now, they shine like scars still healing. One of the best examples is Hokusai crater, whose bright rays stretch almost across the entire planet. These glowing marks remind us that Mercury is not just ancient. It is still being shaped by the universe today, as meteorites continue to strike and leave their luminous signatures. On the side of Mercury, opposite the Great Calorus Basin, lies one of the strangest regions in the solar system. It is called the Weird Terrain. Here, the ground is jumbled into ridges, hills, and troughs that make little sense. Scientists believe this strange landscape was caused by seismic waves from the Calorus impact traveling through the planet and converging on the opposite side. The collision that formed Calorus was so powerful that it reshaped the entire planet, leaving scars on both the near and far side. It is a haunting reminder of Mercury's violent past. Mercury's surface is divided into two main types of terrain: rugged highlands and smoother lowlands. The highlands are heavily cratered and ancient, dating back billions of years. The smoother regions, meanwhile, are thought to have been resurfaced by volcanic activity or lava flooding. This contrast gives Mercury a patchwork appearance, with jagged landscapes standing beside calm, flat expanses. To drift over these regions in thought is to imagine the rhythm of Mercury's history, times of chaos and bombardment, followed by moments of quiet renewal. Despite its overall dark and gray appearance, Mercury has some surprisingly reflective patches. These bright areas are thought to be made of unusual materials, possibly salts or metals exposed by impacts. They gleam against the darker background, catching the light like sparks frozen in stone. These patches may reveal something unique about Mercury's chemical makeup, hinting at minerals not common on Earth. They stand out like quiet beacons on an otherwise muted canvas, reminding us that even in a world of shadows, light always finds a way to shine. Messenger. Spacecraft images revealed something unexpected. Small, round pits on Mercury that appear to be ancient volcanic vents. These vents were once openings where lava erupted to the surface. Over time, they collapsed, leaving behind hollowed depressions. Their discovery confirmed that Mercury was once volcanically active, not just geologically dead. These vents are like chimneys from the past, silent now, but carrying echoes of a time when Mercury's surface bubbled with molten rock. Their presence is one more clue to the fiery forces that shaped this little world. Some of Mercury's scarps, or cliffs, rise to staggering heights, taller than the Grand Canyon's walls. Imagine a sheer drop stretching for kilometers, cutting across the surface in a single massive line. These cliffs are not carved by rivers or wind, but by the entire planet shrinking. As Mercury cooled, its crust cracked and folded downward, lifting vast ridges into the sky. These cliffs are among the most dramatic sights on the planet, colossal reminders of a world pressed in on itself, reshaped not by erosion, but by contraction. Every feature on Mercury's surface tells a story of violence. From craters to cliffs to lava plains, all were born from impacts, eruptions, or contractions. In its first billion years, Mercury endured a period of heavy bombardment that scarred it forever. Unlike Earth, where wind, rain, and life erase such marks, Mercury's scars remain. The planet is a living museum of the early solar system, its surface a record book written in stone. To study Mercury is to look into a time when chaos reigned, when worlds were young and collisions were constant. When Mercury faces the sun, its surface is blasted by light and heat more intense than anywhere else in the solar system. Temperatures soar above 430 degrees Celsius, hot enough to melt lead. Rocks bake in silence, and the ground glows faintly with absorbed energy. Without an atmosphere to scatter the heat, the sun's rays strike directly, turning the dayside into a furnace. For any traveler, survival here would be impossible without protection. Yet in this extreme environment, Mercury continues to endure, a scorched but unbroken world. As soon as the sun sets on Mercury, the story changes completely. With no thick atmosphere to hold the heat, temperatures plunge to minus 180 degrees Celsius. The transition is sudden and absolute, turning the surface into a deep freeze. This staggering difference from furnace to freezer happens within a single day. Mercury is the planet of extremes, where silence rules both burning light and frozen shadow. The night side is so cold that ices can survive, preserved in darkness, while the day side blazes with unbearable heat. No other planet experiences a temperature range as wide as Mercury. From more than 400 degrees Celsius in the daytime to almost minus 200 at night, the swing is over 600 degrees. This is greater than any desert on Earth, greater than even the frozen poles or volcanic regions combined. Mercury is a planet of contrast, blazing heat beside deep cold, extremes balanced within a single world. Its silence makes the contrast even more striking, as though the planet itself breathes in fire and exhales in frost, endlessly cycling between two opposites. One reason for Mercury's harsh extremes is its lack of a true atmosphere. Unlike Earth, Mercury cannot hold on to thick air. Its gravity is too weak, and the sun's heat too strong. Instead, it has what scientists call an exosphere, a thin veil of atoms that are constantly stripped away and replaced. This exosphere is so thin that it would be invisible to human eyes. On Mercury, the sky is always black, even during the day. The emptiness is so complete that you could see stars in the sky while standing under the blazing sun. Though it is almost nothing, Mercury's exosphere contains a mix of elements. Oxygen, sodium, hydrogen, helium, and potassium drift in this fragile layer. These particles do not stay long. They are blown away by the solar wind or escape into space, only to be replenished by impacts or chemical reactions on the surface. The exosphere is like a whisper of breath, constantly fading and returning. It cannot shield Mercury from heat or impacts, but it gives the planet a strange kind of aura, a faint, ever-changing cloud that hovers close to the ground. The solar wind, a constant stream of charged particles from the sun, shapes Mercury's exosphere. These particles slam into the surface, kicking up atoms and pushing them into space. Unlike Earth, Mercury has no thick magnetic field or atmosphere to deflect the solar wind. Instead, it is exposed, battered constantly by the sun's invisible storm. Yet this same process replenishes Mercury's exosphere, giving it a cycle of loss and renewal. In a way, Mercury breathes with the sun, inhaling particles and exhaling them again in a rhythm as old as the solar system. Another source of Mercury's exosphere is micrometeorites. These tiny space rocks strike the surface constantly, releasing atoms and dust. Each impact, though small, contributes to the thin veil that surrounds the planet. Over time, this steady rain of particles keeps Mercury's exosphere alive. It is a gentle reminder that even in silence, Mercury is connected to the wider solar system, always interacting with the streams of dust, rocks, and particles drifting through space. Every collision leaves a trace, adding to the fragile cloud that hangs above its surface. One of the most remarkable discoveries about Mercury's exosphere is that sodium within it glows faintly when struck by sunlight. This creates a delicate yellow-orange aura around the planet, invisible to human eyes, but detectable by telescopes. To imagine Mercury shining with a soft halo is to see it not just as a gray rock, but as a world with a hidden beauty, glowing gently under the touch of the sun. It is a reminder that even the smallest, harshest places can reveal unexpected grace when seen closely enough. On Earth, we are used to winds, clouds, and rain shaping our landscapes. But on Mercury, there is no weather at all. With almost no atmosphere, there are no winds to erode the rocks, no raindrops to carve rivers, and no storms to rearrange the surface. Every crater, every cliff, and every plain lies unchanged, frozen exactly as it was created. The silence is complete. To stand on Mercury would be to feel a stillness unlike anything on Earth, a world untouched by the soft hand of weather for billions of years. Comets that pass through the solar system sometimes leave trails of dust behind them. On Mercury, this dust settles onto the surface and contributes to the exosphere. Each tiny grain carries stories from far away, drifting down to join the smallest planet. In this way, Mercury is constantly gathering whispers from the wider solar system. Dust from ancient comets formed in distant regions of space becomes part of Mercury's fragile veil. It is as if the planet wears a cloak of stardust, gifted by travelers from the deep reaches of the cosmos. Although Mercury has no real seasons, its exosphere does change depending on where the planet is in its orbit. When Mercury is closer to the Sun, the solar wind intensifies, stripping more atoms from the surface and swelling the exosphere. At its farthest point, the effect weakens, and the exosphere becomes thinner. These variations mean Mercury is not completely unchanging. Its delicate envelope of particles rises and falls like a quiet tide in rhythm with its journey around the Sun. At Mercury's poles, where sunlight never reaches the bottoms of some craters, gases may become trapped. These shadowed areas act like natural freezers, preserving particles that would otherwise escape. Scientists believe these regions may hold not only water ice, but also other frozen materials, locked away in permanent night. These hidden pockets are silent vaults of Mercury's history, keeping safe the fragile gases and elements that the rest of the planet cannot hold. They are like sealed jars in a cosmic museum, untouched for billions of years. Even during the brightest day, Mercury's sky remains black. Without an atmosphere to scatter sunlight, the stars shine. Above, even when the sun dominates the horizon. Imagine standing in blinding heat with the sun 3 times larger than on Earth, while overhead, the sky remains a star-filled void. It would be both breathtaking and unsettling, a reminder that Mercury is a place of extremes. It is a world where day and night meet, where the sky reveals eternity even as the ground burns beneath your feet. When Mariner 10 first flew by Mercury in 1974, scientists expected the planet to be geologically dead. Instead, they discovered something astonishing. Mercury has a magnetic field. It was a complete surprise. Small planets usually lose their magnetic fields as their cores cool and solidify. Yet Mercury's field, though weak compared to Earth's, is still active. This means the planet is not as lifeless inside as once thought. Deep below its surface, Mercury's metallic heart still stirs, keeping alive a faint but persistent magnetic shield. Mercury's magnetic field is only about 1% the strength of Earth's. Though faint, it is enough to create a small magnetosphere around the planet. This shield deflects some solar wind particles, though not as effectively as Earth's strong field. The result is a planet that is both protected and exposed, a fragile balance between endurance and vulnerability. To think that such a small world still carries a magnetic field is humbling, reminding us that even the smallest planets can hold great surprises within their depths. The existence of Mercury's magnetic field suggests its core is not fully solid. Instead, part of it remains molten, churning with liquid metal. Scientists believe the core is a mixture of iron and sulfur, kept partly molten by the slow cooling of the planet, and possibly by tidal forces from the sun. This hidden ocean of liquid metal is what generates Mercury's magnetic field. Though we cannot see it, the molten heart of Mercury beats quietly, a reminder that even silent planets can carry a hidden fire within. Mercury's core takes up about 85% of its total radius, far larger than Earth's proportion. It is as though Mercury is almost entirely core, wrapped in only a thin, rocky shell. This unusual structure is one of the great mysteries of the solar system. How did such a small planet end up with such a massive metallic center? Theories include giant impacts or early solar processes, stripping away lighter material. Whatever the cause, Mercury remains unique, a planet that is essentially a heart of iron traveling endlessly around the sun. Scientists suspect that sulfur plays an important role in Mercury's core. Sulfur lowers the melting point of iron, keeping parts of the core liquid even after billions of years. Without sulfur, the core might have solidified long ago, leaving Mercury without its magnetic field. This unexpected ingredient reveals that Mercury is more chemically diverse than once assumed. The presence of sulfur challenges old models of planet formation and shows that even the smallest planet carries secrets about the building blocks of the solar system. Mercury's magnetosphere is not calm. When the solar wind collides with it, magnetic tornadoes form, swirling funnels of charged particles that slam into the surface. These storms can strip atoms from the crust and feed them into the exosphere. Unlike Earth, Mercury has no thick atmosphere to soften these blows. Each magnetic storm is direct, raw, and powerful. To imagine these invisible tornadoes twisting across Mercury is to picture a silent storm of energy, unseen but real, shaping the smallest planet every day. Mercury's magnetosphere is constantly reshaped by the solar wind. It compresses on the day side, stretches into a long tail on the night side, and shifts endlessly as solar storms pass. This fragile bubble of magnetic protection is small compared to Earth's vast magnetosphere, but it is still enough to create auroras, faint glows of energy near Mercury's poles. These auroras are not visible to human eyes, but spacecraft have detected them. Even Mercury, in its quiet way, carries a dance of light deep within its magnetic shell. Studying Mercury's magnetic field is important because it challenges our understanding of how magnetism works on planets. Large, active planets, like Earth, are expected to have strong fields. But small, cooling planets, like Mercury, should not. Yet Mercury defies these expectations. Its magnetism is a puzzle, a sign that we do not fully understand the rules of planetary interiors. By studying Mercury, scientists gain insights into not only its own secrets, but also the forces that shape all rocky planets, including our own Earth. Mercury's magnetic field and interior suggest that it is cooling slowly, not quickly as once believed. Its oversized core releases heat at a measured pace, keeping part of it molten. This slow cooling explains why Mercury still shows signs of geological activity, like the formation of hollows and shrinking cliffs. The planet, though ancient, has not gone completely cold. It is a survivor, still carrying warmth in its depths, still evolving in ways we are only beginning to understand. Scientists believe Mercury experiences occasional quakes, not from tectonic plates like Earth, but from its crust adjusting as the planet shrinks. These quakes, called Mercury quakes, would rumble quietly through the ground, caused by the slow collapse of ridges or the shifting of scarps. Though no instruments have directly recorded them yet, models suggest they are real. If you stood on Mercury, you might feel a faint tremor beneath your feet, a gentle reminder that the planet is not entirely still. Based on spacecraft measurements, Mercury is thought to have 3 main layers: a solid crust, a large iron-sulfur core, and a molten outer layer of the core. Its mantle is very thin compared to Earth's. This makes Mercury unusual, more like a metal ball wrapped in stone than a traditional planet. This structure is why its density is so high and why its magnetic field persists. It also means Mercury has fewer resources for volcanoes or tectonic activity today, leaving it as a world dominated by its inner metal heart. Mercury's massive core cools more slowly than scientists expected, partly because of its size and partly because of insulating layers above it. This slow cooling may explain why Mercury still shows hints of activity, such as the presence of hollows. It also means the planet has been evolving for far longer than anyone thought. Instead of dying quickly after its birth, Mercury has stretched its geological life across billions of years. This endurance is yet another of its quiet mysteries. The Sun's powerful gravity not only holds Mercury close, but also pulls on its interior, creating tidal forces. These forces generate heat deep within the planet, keeping part of the core liquid. It is similar to how Jupiter's pull warms its moon Io, but on a smaller scale. This tug of war between Mercury and the Sun helps sustain its magnetic field. In this way, Mercury's relationship with the Sun is not just one of orbit and light, but of deep, hidden heat as well. Mercury's interior and magnetic field are shaped by forces we cannot see. molten flows, sulfur chemistry, tidal heating, and magnetic storms. These invisible players write Mercury's story in silence, beneath its cratered crust. Though the planet appears still and lifeless from the outside, its hidden depths are alive with quiet motion. To think of Mercury is to realize that appearances can be deceiving. Beneath the cold rock lies a restless heart, shaping the smallest planet with mysteries as deep as the sun's pull itself. Despite decades of study, Mercury's interior remains a puzzle. We know it has a giant core, a molten layer, and a faint magnetic field. But why its structure is so different from other planets is still unclear. Was it shaped by collisions or by the sun's influence during its formation? Did it once hold more material that was stripped away? Mercury keeps these answers hidden, waiting for future missions to uncover them. Even as we drift through these 100 facts, some truths about Mercury remain just out of reach, like whispers carried away into the night. It may sound impossible, but Mercury, the closest planet to the Sun, holds water ice at its poles. The secret lies in deep craters that never see sunlight. These shadowed regions stay cold enough to preserve ice for billions of years. While the dayside surface bakes in blistering heat, the poles remain locked in eternal frost. Radar observations confirmed the presence of these icy deposits, showing that even in the most unlikely places, water can endure. Mercury's ice is a quiet contradiction, a reminder that the universe is always full of surprises. At Mercury's north and south poles, some craters lie in permanent darkness. Because the planet has almost no tilt, sunlight never reaches into these deep pockets. Temperatures here are unimaginably cold, colder even than some regions of Pluto. In these frozen traps, water ice can remain stable for billions of years, untouched and unmelting. These craters are natural freezers, preserving a record of ancient water that may have come from comets or asteroids long ago. In Mercury's silence, these shadows keep their secrets safe. In the 1990s, scientists using powerful radar beams detected unusually bright reflections from Mercury's poles. These reflections matched the signature of water ice. Later, spacecraft confirmed that the icy patches were real. They extend across craters and are often covered by a thin layer of insulating dust. This discovery shocked astronomers. To find water ice so close to the Sun was almost unthinkable. Yet there it was, gleaming in radar echoes, waiting to rewrite what we thought we knew about the smallest planet. Alongside the ice at Mercury's poles, scientists have also found hints of organic materials, dark, carbon-rich compounds that may coat some icy patches. These materials could have been delivered by ancient comets, carrying the building blocks of life. Though Mercury itself is not a place where life could thrive, the presence of such materials shows that the seeds of chemistry are scattered everywhere. Even the harshest world can carry traces of cosmic ingredients, tucked away in the shadows, where time stands still. The polar craters of Mercury act as natural time capsules. Shielded from sunlight, they preserve ice and organics for billions of years. These frozen vaults may hold clues about the early solar system, about the delivery of water, about the chemistry of comets, and about the materials that shaped Earth and its neighbors. To peer into these craters is to look into the past. In Mercury's eternal shadows, the story of water in the solar system is still being written. The first spacecraft to visit Mercury was Mariner 10, launched by NASA in 1973. It flew past the planet 3 times in 1974 and 1975, capturing the first close-up images. Before Mariner 10, Mercury was just a blur in telescopes. Afterward, it became a world of craters, ridges, and mysteries. Mariner 10 also discovered Mercury's magnetic field, shocking scientists who thought the planet was geologically dead. Though it only mapped about 45% of the surface, Mariner 10 opened the door to Mercury's secrets, beginning our modern exploration of the innermost planet. Mariner 10 gave us our first glimpse of Mercury, but its mission was limited. The spacecraft used Venus for a gravity assist, which locked it into a trajectory that always showed the same side of Mercury during flybys. As a result, more than half the planet remained hidden. For decades afterward, the unseen regions of Mercury were a blank on our maps. This partial view left astronomers hungry for more, knowing that the planet's other half still waited in shadow, untouched by human eyes. Launched in 2004, NASA's Messenger spacecraft became the first to orbit Mercury. After a long, looping path that included flybys of Earth, Venus, and Mercury itself, Messenger finally entered orbit in 2011. It spent 4 years circling the planet, mapping its entire surface in stunning detail. Messenger revealed a world more complex than anyone imagined, with volcanic plains, strange hollows, and icy poles. It turned Mercury from a mystery into a well-studied planet, though it also raised new questions. Messenger's discoveries transformed our understanding of Mercury. It confirmed the presence of water ice at the poles, found organic materials, and showed that Mercury once had widespread volcanic activity. It also revealed unexpected chemical compositions, suggesting Mercury formed in unusual conditions. Perhaps most surprising, MESSENGER detected signs of a shrinking planet, with scarps and ridges still forming as the core cooled. In every way, Mercury proved to be richer and stranger than scientists had guessed. In 2015, after years of exploration, MESSENGER ran out of fuel. Instead of drifting aimlessly, the spacecraft was deliberately guided into Mercury's surface, where it left a small, final crater. Its mission ended, but its legacy continues through the mountains of data it sent home. MESSENGER gave us the first complete map of Mercury and showed that even the smallest planet holds endless wonders. Its crash was not an ending, but a quiet merging with the world it studied so faithfully. Launched in 2018, Bepi Colombo is a joint mission between the European Space Agency and the Japanese Aerospace Exploration Agency. It is on its way to Mercury, using a series of flybys to gradually slow down and enter orbit. Bepi Colombo carries 2 orbiters, one to study Mercury's surface and another to study its magnetosphere. When it arrives in 2025, it will provide the most detailed observations yet, continuing the story that Mariner 10 and MESSENGER began. Reaching Mercury is far more difficult than it seems. Unlike outer planets, which can be reached with gravity assists pushing outward, getting to Mercury requires slowing down against the pull of the Sun. Spacecraft must use repeated flybys of Earth, Venus, and Mercury itself to gradually lose energy. Bepi Colombo's journey will take 7 years and 9 flybys before it can settle into orbit. This long and winding path shows how challenging it is to explore the innermost planet. When Bepi Colombo begins orbiting Mercury, it will study questions left open by MESSENGER. It will examine the composition of Mercury's surface, the mysteries of its hollows, and the details of its magnetic field. It will also provide fresh insights into the ice at the poles. For the first time, 2 orbiters will work together, one focusing on the planet itself and the other on its magnetic environment. Bepi Colombo is not just another mission. It is the next chapter in a story of discovery that stretches back centuries. Mercury has a special place in the history of science because its orbit helped confirm Einstein's theory of general relativity. The strange precession of its perihelion, unsolved for decades, matched perfectly with Einstein's predictions. Today, missions like Bepi Colombo will continue to test relativity by measuring Mercury's orbit with exquisite precision. The smallest planet thus plays a giant role in confirming the deepest truths of physics. For now, robotic spacecraft are our only visitors to Mercury. But some scientists dream of future missions that might include landers or rovers. A human mission is unlikely given the planet's harsh environment, but robotic explorers could one day walk its surface, drilling into the crust or studying its icy shadows. Mercury may never host a colony, but it will always hold a special place as a world of extremes, waiting for each new generation of explorers to uncover its secrets. Mercury is named after the Roman messenger god, known for his speed and agility. The name fits the planet's swift orbit and elusive appearances in the sky. In mythology, Mercury carried messages between gods and humans, traveling quickly between realms. The planet reflects this role, a small, fast-moving wanderer that links us to both the sun and the stars. Its name ties our science to our stories, blending ancient myth with modern discovery. In astrology, Mercury is said to rule communication, intellect, and travel. Its quick movement through the sky made it a symbol of thought and speed. Even today, people talk about Mercury retrograde, a time when the planet appears to move backward in the sky. Though this is only an optical illusion, it has become a cultural idea associated with confusion and miscommunication. Whether one believes in astrology or not, Mercury's influence on human imagination is undeniable, stretching from ancient temples to modern conversation. The ancient Maya also watched Mercury carefully. They associated it with the underworld, seeing its brief appearances near sunrise and sunset as symbolic of journeys between realms. To them, Mercury was not just a planet, but a spiritual traveler, moving between light and darkness. These associations show how deeply human cultures have always connected the sky to meaning. Mercury, though small and elusive, carried weight in stories and rituals across the world. For cultures in Greece and Rome, Mercury's dual appearance as both a morning star and an evening star inspired myths of duality. It was a planet with two faces, shifting identities, and quick changes. This sense of duality still clings to Mercury today. It is both hot and cold, both scarred and smooth, both old and subtly active. Its very nature is a balance of opposites, making it not just a planet of speed, but also a planet of paradox. In medieval Europe, Mercury was linked to the element quicksilver, or liquid mercury. Alchemists saw this silvery metal as mystical, a substance of transformation. They associated it with change, communication, and magic. The connection tied the planet Mercury to ideas of mystery and transformation on Earth. Even today, the word mercurial describes someone who is quick, changeable, or unpredictable. The planet's name continues to echo in our language, shaping the way we think about motion and change. Even though Mercury is one of the closest planets to Earth, it is one of the least studied. Its proximity to the Sun makes it difficult to observe and even harder to visit with spacecraft. This elusiveness has kept many of its secrets hidden, even in modern times. While Mars and Jupiter often dominate the spotlight, Mercury quietly circles the Sun, almost unnoticed. Its nature is to remain in the background, quick and subtle. A reminder that sometimes the most fascinating stories are those that hide in the shadows. One of Mercury's strangest features, the hollows, remains a mystery even today. Unlike craters, these bright depressions look fresh and youthful, as though they were formed recently. Scientists debate how they appear, whether through the loss of volatile elements, solar radiation, or processes we do not yet understand. No other planet shows hollows in the same way, making them uniquely Mercurian. Their unexplained presence adds to the planet's aura of secrecy. In a world billions of years old, new mysteries still appear, as if Mercury refuses to let us fully understand it. Despite spacecraft visits, detailed maps, and decades of study, Mercury still holds many secrets. We do not fully know how it formed, why its core is so large, or how it continues to generate a magnetic field. The planet offers hints, but withholds full answers. It is like a locked book, giving us pages here and there, but never the entire story. This quiet resistance makes Mercury endlessly fascinating. The more we learn, the more questions it raises, keeping us forever curious about this small but mighty world. Studying Mercury is not just about understanding one planet. It helps us understand the processes that shape all rocky worlds, including Earth. Its dense core, shrinking crust, and icy poles provide insights into planetary formation, geology, and magnetism. By exploring Mercury, we learn about the earliest days of the solar system and the hidden rules that govern planets. Mercury is a key to the past, a messenger carrying knowledge across time, reminding us that even the smallest planet can unlock the biggest mysteries. Mercury may not have rings like Saturn, storms like Jupiter, or oceans like Earth, but it has its own quiet significance. It is the first planet from the Sun, the swift traveler, the ancient survivor. It has endured bombardments, collisions, and searing heat, yet still carries traces of water, ice, and organic material. Its paradoxes, hot and cold, old and active, elusive yet important, make it a world of balance. Mercury's place in the cosmos is not to dazzle with spectacle, but to teach us that even the smallest worlds can carry the greatest lessons. And so, we come to the end of 100 unknown facts about Mercury. The smallest planet, yet one of the most profound, has shared its secrets with us, gently, one by one. We have traveled through its fiery days and frozen nights, its cliffs and craters, its ancient myths and modern mysteries. As you close your eyes, let Mercury drift quietly in your thoughts, a tiny world circling close to the sun, endlessly swift, endlessly patient. May its story remind you that even in silence and shadows, there is beauty, wonder, and wisdom. Thank you for listening, for dreaming, and for letting curiosity guide you into calmness tonight. Rest well, and let the stars keep you company. Good night.